In this video, I will perform the Gold Belt Kata in JavaScript. So I've got the project open here. Let's just walk through the steps really fast, and then we'll walk through basically one of the ways that we can solve this problem. So we'll start off, we'll create a test to demonstrate the as-is functionality. It's not going to pass right away. We're then going to refactor the code just enough to get the test to pass. We'll spend quite a fair amount of time going through these first two steps. After that, we'll refactor a little bit to create some branching points. And I'll talk through our strategy there and what our options are. Then we'll add a test that shows the ideal state, and then finally we'll make the code, we'll write code to make the test pass. And then we'll refactor and clean up a little bit. These next four steps will be the next big chunk that we'll do. And then the last four steps are probably going to go pretty quickly. So we'll add a failing test representing one of the bugs. We'll fix the bug in production or in the production code. We'll make all the tests pass and then do one more final cleanup. As we go through this, I'm going to show you one way that we can solve this problem. It is not the only way. There are probably a million different ways that we can solve this problem. I'm simply going to show you one particular way that will work. So let's start off. We've got our node project here. We'll start off with our npmi, as we typically do, not np. Let that run. I'll go ahead and create our test folder and our test file. All right, so we've got that up and running. From here, I'll need to install a test framework. I could pick any one of them. I think Mocha Chai tends to be the most popular these days in terms of my students, so I will go ahead and use Mocha Chai, but any of the test frameworks would work just fine. It's not particular for this particular exercise. So we'll npmi Mocha Chai big D for save dev. And let me change my test command. All right, let's go ahead and create a quick test. Alrighty, so this should pass. Let's go ahead and attempt it really quickly. Perfect, so we have our test framework up and running. We are ready to go. So again, going back to our README, we want to create a test that demonstrates the as-is functionality. So looking at the project, effectively we just need to import main and await it. So we are going to need this to be async. And we'll need to import that from source/app.js. All right, let's go ahead and run this again. See what our next error is, if we have an error. All right, so we do have an unknown error. It could not find a file path. So excellent. We are failing because it's trying to get to the physical file, and it will try to get to the database as well. So it's not able to get to the file. It's not able to get to the database. So we are getting our failure. So now we are ready to start fleshing out this test and making it work the way we want it to work. So let's think through what we need to do. So the project itself, the program, is going to read from this file, which it cannot find. So it's going to read from this file. It's going to take those transactions that are in that file and it's going to import it or load it into the database. So we'll need to make sure the database is set up. We'll need to make sure there's a file where it can access it. And then we'll need to run through everything so that it reads through, loads everything. We'll run through main. Once that's done, we'll need to assert probably a couple things. So we'll assert that the records got into the database. And we'll also need to assert that the file itself got deleted. So that's the idea here. So let's go ahead and walk through the code. Let's start fleshing out that side of it. So we'll start off by basically creating our database. So let's just say reset database. And then we'll need to create and copy the file that we're going to use. So we'll say file CSV file path equals, and let's just create a helper method here inside the test that will copy the file that we're going to use. So we'll say copy example file 1. That's good enough. So we'll say copy example file 1. So that'll create it and then give us back the path. Now that we have that, as well as we're going to need the connection information from the database, we're going to need to set up in main, before we call main, we'll need to set up that we'll use these paths. So there's a couple of different ways to do this. I go through this in another video. We can either create new constants that are the original versions of our configuration settings, our constant values, or we can do overrides. I will just do an override. It seems a little bit simpler in my mind. Certainly the original version would work just fine too. So again, this is one of those decision points. There's not really a right and wrong. What we'll need to do though is effectively override the CSV file path and the connection information. So let's look at, so we're going to need the host, the username, and password for the connection information, and we'll need the path for the file. So let's go ahead and set those up. We'll say override connection info, and this will be our local. So we're going to use our local host username and password. So whatever we're using on our local machine. So I can set those up as constants in JavaScript. I can create that as an object. I can pass the object about. There's a few different ways that we can do this. I'll just do these as constants just to keep it simple. So local host, which is ironic, local username and local password. And then we'll also override the CSV file path with our CSV file path. So we get those set up. Now I will want to make sure that for another test that those are reset. So let's go ahead and do that really quickly. We will try finally, and we will reset connection info and reset CSV file path. So we'll get those reset. All four of these methods, the two overrides and the two resets, are going to be inside the app.js file. So we'll get to those in just a moment. Then we'll run through main, and then once that's done, we need to make sure that we have the records as well as the file got deleted effectively. So we'll say const transactions equals retrieve transactions from database. And let's expect, so we're going to need our expect. We'll import that from Chai. We will expect that our transactions to have length of 3. Now, I could also test for specific values. I could test for column values and row values. I'm not going to do that in this particular case. I could do that in another test if I wanted to. Really, at this point, if I can get records out of the database, I'm probably in good shape. So we'll do that, and then we'll finally make sure that, let's go to FS. We'll make sure that the file itself got deleted. So let's import FS from FS. Exists CSV file path to be false. All right, that is a property. Perfect. So that is our test set up. Let me just create some more room so we can see it. So again, we're going to reset the database. We're going to copy our file over. We're going to override the connection information. At the end, we will reset the connection information. We'll run through our test. That's all that's really happening. This is the method under test, the function under test. We'll retrieve the transactions, make sure there's 3 of them, and make sure the file got deleted. So at this point, this is certainly not going to pass. What I need to do is get this to a point where I can at least run this test and get an assertion error. Right now, I'm going to have missing methods, missing functions, missing objects. So let's create those first. I'll start off with, just from the top, we'll create reset database. And for now, I'm just going to create a to-do. We'll need copy example file path 1. Return null. We'll come back to the overrides in a minute since they're not in this file. We're going to need to retrieve. And we'll return null. I think that's it here. So now we just need these methods that we're going to import from app.js. All right, let's go ahead and get these at least placeholders set up. Host, username, and password. I lost my to-do. And then we'll need our resets. And then finally, let's export these. All right, I think that has everything ready to go. Let's go ahead and run the test again. Let's see if we can get to the same. Okay, no, okay, yes. So in JavaScript, I will need to define these objects. So let's go ahead and create those. Let's try that again, run the test. Excellent, we're back on the same error that we had before. So everything's looking good. I think we're pretty much done with step 1. Let's review step 1 real fast. Create a test to demonstrate the as-is functionality. It may or may not pass, and it certainly does not pass. We'll use example1.csv as a working file. So we're ready to make sure that we can make the test pass. So let's head back into our test here. there is quite a bit that we're going to need to implement here. I'm going to start off with the test file itself. I'm going to do as much as I can in the test file before I need to get into the production code in app.js. That way I'm minimizing the amount of changes I'm making there. I want to do as much outside of app.js as possible for this very first test. So we can just start off with, let's just start off at the top, reset the database. So in the reset database, we'll import our create DB. Our create DB is going to create our connection to the MySQL database here. Perfect. And then we will execute some commands to create our transaction table. So this looks pretty good. I am going to parameterize this so that I can pass in the host username and password. All right, so 3 references, not a big deal. Let's change those. Username, also 3 places. And then finally password, also 3 places. All right, so these constants are no longer used. That looks good. We are exporting it. Excellent. Let's go and import this in and use it. I'm going to rearrange my usings. Create DB from src createdb.js. All right, so our reset database. This is async, so unfortunately I am going to have to propagate async up the chain, which is highly unfortunate. This will be localhost, local username, and local password. All right, so let me focus on the await first. There we go. And this is already async, so we're in good shape there. Now, localhost username and password, let's go ahead and set these up. So this will be localhost. I believe this is, no, this is root. And then this is my super secret password. All right, so that should be ready to go. Let's run this again and see if we get a failure or if it succeeds in dropping and recreating the database. All right, so no error. I'm going to assume that createDB did in fact work. I'm not seeing any other lines or messages or anything along those lines. In createDB, you'll notice we don't have a try catch. So this should definitely fail if there was a problem. All right, so that looks pretty good. There's our reset database. Now let's get on to copy example file 1. Effectively, we just need to pull from wherever the example file is today, which is in files. So we'll say const source file path equals, and this will be, so this is going to execute wherever we run the npm test command, which is generally going to be from the root of the project. So we'll go from here, we'll go into files and then get example file 1.csv. So my destination file path, this could be anywhere I want. I could put it somewhere like on ctemp, so the temp folder on the C drive, create that out. I could create a new folder in here. I'm going to actually create a new folder inside this project. I'll call it test data, and I will make sure that test data exists prior to actually executing. So let's create a const destination folder path equals test data. And then so our file path is going to be folder path plus a / plus accounts.csv. I'm going to use the accounts.csv just to keep in sync with what we were doing here, which is accounts.csv. I can leave it as an example file 1. It really shouldn't matter the actual name of the file. So I'm going to do it as accounts.csv so it's clear that we are using it as a part of testing, and it's going to be similar to what we were doing with the production code. So from here, I do need to make sure the test folder exists. So we'll say if not fs.exists destination folder path, then we will create make dir destination folder path. So we need to make sure that folder is created if it does not yet exist, and then we will copy the file from source to destination. Finally, let's return destination file path. All right, at this point, this part of the test should succeed, and I should see a test data folder. There it is, along with accounts.csv. Let's see if we get the same error, and we do. Excellent. So looking pretty good there. Now, before I move on from here, I do want to note test data is going to be checked into version control. So if I don't want that, because this test data is basically going to be files that we generate as a part of tests, there's going to be a lot of churn. I don't want that just going into the version control repository over and over again. So let's exclude that. So let me get back to the get_ignore file. So I'm going to open this up. And get_ignore at the very bottom, I'm going to add test data backslash, basically to say test data folder anywhere is going to be ignored and anything inside it is going to be ignored. You'll notice that Visual Studio Code actually grays this out for us. It tells us this is not going to be checked into version control. Perfect. So that's now, I can put as many files as I want inside the test data folder. It will not get checked into version control, so it won't create a bunch of churn by checking in files that are just used for the tests. All right, so that's looking good. The only other method in here is retrieve transactions from database. So let's go and implement this. I'm going to do some copy and paste inheritance from our app.js. So we'll create our connection, and then we will do connection.query await query. Let's go and copy those over. So there's our connection. This does need to be async, so sadly I will need to propagate that. All right, so there's our connection. We've awaited that. Now we need to query. All right, it's not giving me my IntelliSense as I was expecting. Oh, import, that would help. Now we're getting it. There we go. So this is simply going to be select. We're going to select all the data from the table. I'm just going to do a select star. Let me make sure this is singular. It is in fact singular. So this is going to select star from the transaction table. We're going to simply pull those back. And we can return that. Now, I believe that when we return this, it's actually going to be a complex thing. We may want to use, okay, yeah. So it's going to be the query result and the field packets. So the results is the query result, and let's see if we can find the name of that. So it's a promise of T and field packet. So it's actually result, and then result bracket 0 will be the actual results. Let's call them records, just so that we don't use the same word, and we should be able to return records, which is a query result. Yeah. All right, so I think that's going to get us what we need. Let's do our test now, see what happens. We should still get an error on the main. And we do. I'm going to comment out main for a moment, just so that we can see if we can get our length, see if we got our query back. All right, so host is not defined. Right, it is not defined. These constants also need to be changed, or changed to use a constant, not host. All right, let's try that again. Excellent. So we are querying to the database. We got 0 records. We were expecting 3. That's exactly what we were hoping for. So that looks good. All right, so we are looking like we're in pretty good shape here. This looks like all the code that I'm going to be able to do here inside the test. We're now ready to get to the app.js file. So let's go ahead and head down there. We're going to implement these. I want to start off with the resets, because all we're really going to do on the resets is we're going to say override, and we're just going to pass null in for these, or nothing, which I think makes just as much sense. Let's be explicit. All right, and then override host, or override CSV. All right, so now on these, what we're going to need to do is we're going to need to hold on to these. And I mentioned we're going to use the override approach. So all we're going to do is create fields that represent the overridden values. So looking up at the top, we just call these host username, password, and CSV file path. So we will just use override as a part of that. So host override equals host, username override equals username, password override equals password, and then finally CSV file path override equals file path. All right, let's create these. So this will be let CSV file path override equals, we'll just default these to null. There we go. Username override equals null. I'm going to re-alphabetize these. Excellent. All right, so we're in pretty good shape here. That is all set up and ready to go. Not really doing much, just holding on to some values. I'm now ready to use these to change the production code. So here's where we're making a potentially dangerous change. So we need to be careful about this. Effectively, what we want to do is if these values are specified, if they're not null, then we use those. Otherwise, we'll use whatever we were doing before. So let's start with CSV file path. We'll notice that it's used in 3 places. So the one where it's defined and then 2 others. So here, let's go ahead and just create CSV file path equals CSV file path, and let's rename this to use this variable. The reason we're doing this is I want CSV file path to be used in exactly one place. Now that that's done, I'm ready to do my override. So in JavaScript, I can simply do the OR operator, the pipe operator. So we'll say use CSV file path override if it's specified. Otherwise, we'll use the regular constant we were using before. So we should get the exact same error. We'll do the same thing on host username and password. These are only used in one place, so I can simply inline these declarations right here. So we'll say host override or, username override or, and then finally password override or. All right, now that I have all that set up, let's rerun the test. We have a passing test. Now I do have an async problem. Something didn't finish. So I probably have a bug in the code. Let's see if we can figure out where that's happening. So there's our await. We are doing await there. I bet it's not closing this. So let's do a try. Finally, await connection dot, I think it's end. Let's see if that gets rid of it. There we go. Now I've closed the connection. Now everything is closed and happy. Excellent. We now have a passing test. Let's head back. So we wanted to refactor just enough. It is a good time to check in our commit our changes. So let me open up Git extensions here. I need to open this repository. Let me grab the path. And let's make our commit. Created an initial test, let's call it a system test, to verify the transaction loading functionality. Excellent. Let's go ahead and commit that. If I did have a central repository, this would actually be a good one to push. Let's go ahead and get that available for everybody else, but I don't have one of those, so we won't actually push it at this point. So that takes us through the first 2 steps. For step 3, we want to refactor to add branching points, and then we'll show that the test still passes. So let's talk through the refactoring that we're talking about here, the branching points. So when we're saying branching points, I don't mean version control branching points. I mean logic branching points. So conditionals, if statements, switch statements, polymorphism, anything along those lines. There are a couple of different dependencies that we have in this particular project that we might want to mock or stub. Those 2 dependencies are the database and the actual file itself. So let's talk through those really quickly. Why would you want to mock these out or stub these out? And do we want to do that in this particular case? So starting with the database. If your team owns the database, if you're the team responsible for pushing schema changes and deploying the actual database into the production environment along with the application itself, you own that database. In that particular case, most of the time I would suggest you probably shouldn't mock out that database. You own it. So you can just create a local database instance and query against that with your acceptance tests. Generally, it's going to be fast enough for what you're trying to do with acceptance testing. However, if the database is too big or it's very slow, there's too much data, too much schema, something along those lines that really slows down your tests, that might be a reason to mock it out. Outside of that, if your team does not own the database, then I definitely recommend mocking or stubbing your database interactions. The reason for that is that schema is not in your control. You cannot control that. So you want to be able to test what happens if someone changes a schema on you. They change a column name, they remove permissions, maybe the database goes down. So those are things that are outside of your control. That would be a good reason to mock that out or stub that interaction with the database so that you can verify what happens in your app when those situations occur. It's a lot easier to simulate those conditions. So to me, that's the big driver. Does your team own and control this particular database? If you control it, maybe you don't need to stub it out. If you don't control it, maybe you do want to stub it out and mock it out. So for our example, we're going to pretend like we don't own the schema. So some other team owns that database schema. We're only creating it just to be able to create one locally so we can test it, but some other team owns that schema. So we will, in fact, stub or mock the database interaction. Let's move on to the second one. The second one is the file system. Why would you want to stub or mock a file interaction? Well, the short answer is you generally always do. The reason for that is not that files are necessarily complex. It's not about ownership. It's really about if you need to test specific situations with file interactions, such as permissions problems, or a file is locked, or the file gets deleted halfway through reading it. These situations are very difficult to reproduce in an actual system test. It starts getting mind-bogglingly difficult. So instead of having a test coordinate all that, what we generally do is we get to the point where accessing the file is 1 or 2 lines of code. Then we can stop or mock that out with throwing an error. We could throw a permissions error. We could throw a file lock error. Whatever the exception is or error is we want to throw, we can simulate that through code and make sure the rest of our application deals with it correctly. Maybe it prompts the user to enter new credentials, or it tells them, hey, we couldn't access it. Do you want to try again? Whatever it is we need to do. So those are the reasons why you might want to mock these out. I'm going to mock both of them out. I'm going to create interactions for both the database and the file system. And as we do that, I'm going to use 2 different patterns. So there's lots of ways to do these. Don't think that these are the only ways I'm going to show you. There's lots of ways to do these interactions. I'm going to, since in the Gold Belt we're learning the facade pattern and the strategy pattern, I'm going to use both. I'm going to use the facade pattern for the database, and I'm going to use the strategy pattern for the file interaction. In the real world, I would probably use strategy pattern for both, but in this case, I want to show how we can use each of these patterns as a part of what we're doing with the code. So that's the idea here. We want to set up the branching points, and I'm going to use a facade pattern and then a strategy pattern. So let's head into our code. Let's see what we've got going on. Now remember, we have a safety net. We have a system test to make sure that the app will still work once we're done with this refactoring. So let's start off with the database first. Let me collapse read CSV. Insert transactions into database is the only place where we're referencing the host, which means it's the only place where we're actually dealing with the database. So here, I want to introduce a facade that's going to hide us from a lot of the code that we're doing here. There's a few different ways I can do this, but probably the easiest way is to create one of these facade objects and then simply call into it. So let's do that. So we'll say, I'll create my facade as, I'll just call it a database. So we'll say database equals new database. So we're going to pass it the host, user, and password so we can connect. That is going to simulate, excuse me, this code right here. Once we do that, we're going to for each over our transactions. We'll do that inside this code here. The database doesn't need to know about that, but we are simply going to connect to the database and insert the record here. So this will simply be await database.insert transaction. And that looks like it's going to be it. Now, finally, I do want to dispose of this. So let's get that set up. So we'll say try. Finally, we'll say database.dispose. This will need to await. And this is the unfortunate part about async and await. I'd like to be able to just say, hey, insert the database transaction, dispose of it. Why should I care whether or not you're async? Unfortunately, JavaScript's implementation requires you that if you use async downstream, you have to now make upstream methods async. And that is just a bad, bad design. So if anybody is listening in the JavaScript world, please fix your stuff. We don't want to await things if we don't need to. You should not have to forcibly make callers know about the implementation details of the downstream methods. That's just bad design. All right, so we do have another problem here, which is when we create the database, this also needs to await. And I can't really do an async constructor. That's not going to work. So I could do a factory method to basically create the instance. I could move the create connection in. I'm going to do a factory method just because I think that's going to make a little bit more sense. So we'll say database.create, host username and password. This will be awaited because that is going to need to actually do the connection. So again, I'm having to think through await and async as a part of my actual method design. That's a horrible, horrible thing to do to other developers. All right, so here's our facade. Pretty clean, pretty simple. We now need to create our database. I'm going to do this in a new module. So we'll create a new file. We'll just call it data.js. And here we're going to create our class database. Now our database is going to need a create method. Let's go ahead and export this so that it's available. So we will import from data.js. All right, so that's looking good. Create doesn't exist. Let's go ahead and create that. No pun intended. Static create, and this will be, is it async static? Static async. Create host username password. And then we're going to need an insert transaction. And then finally a dispose. All right, there's our methods. Let's go ahead and implement these really quickly. So we'll start off, and I'm going to cut from this file and move it into the other so I know that it's done. So this will be a part of create. That will create the connection, and then I will simply return a new database with the connection. So here we're going to need our constructor. And I believe in the newer versions of, username. The newer versions of JavaScript, you can do # connection. I don't know that I'm really using the newer version, nor do I know that I really care, because it's really just a convention that tries to enforce it, and don't get me into the theory behind that. Let's not go there. So we'll just say this _ connection equals connection. Then dispose, this one's going to be easy. It's just await this _ connection end. Insert is also going to be fairly easy. We just need to get the values out and then insert using our insert SQL. Here we go, and insert. All right, so this for loop needs to go away because we've already got it. That looks pretty good. So we pulled everything over. Let's just make sure, yeah, this needs to be this _ insert SQL transaction. That all looks about right. So we've basically taken the code that we already had, we've moved it into a facade so that we can set up the branching pattern. Let's go ahead and run our test again, make sure we still pass. All right, we did not, I need an import, which is excellent. So you'll notice this facade is a good facade because we're not using MySQL any longer in app.js. So that I'm gonna get rid of that and clean that up, which is a good indication that the facade class is well defined. Let's try our test again. Perfect, we are still passing. So that's a good branching point for the database. Now let's move on to the branching point for the file. So the file interaction, we're gonna have two interactions here. We're gonna have one that's a part of reading the file, reading the CSV file, which will be this line here. So this line's gonna go away. The other is going to be in the RM sync, so the remove the file sync. So this also needs to be delegated out. So we're going to delegate this out to a strategy pattern. Effectively, what we need to do here is, in addition to creating a CSV file path, we're actually going to create some sort of strategy, something that helps us deal with, interact, or manage the file. So I'm going to call it a file interactor. So let's just create that really quickly. So we will say const file interactor equals CSV file interactor dot create. I'm going to create a static method as a part of my strategy pattern. You don't need to do that. There's other ways to do that, but I'm going to do it that way so that I can hide the implementation from my code here. So we'll pass it the CSV file path. So now that I've got my file interactor, we will change these. I'll pass that in, and then here what we'll do is we'll say file interactor dot delete file. So CSV file path now is only used in the create method. It's no longer used in these other two. I'll need to implement delete file, but I'll also need to change read CSV file. So let's do that really quick. Read CSV file. This is no longer a file path. It's now a file interactor. So we're going to comment this line out, and instead we're going to say lines equals file interactor, and I'm just going to create a method that gives me the lines. We'll say read lines. So that will do this logic for us, but it's going to do it as a part of the file interactor instead. So that cleans up everything else, makes it all one-liner. That looks pretty good. So let's go and now implement our file interactors. So we'll create a new file again. These will be file interactors.js. And we'll start with our class CSV file interactor. Let's export it. And then let's import it. And again, FS is going to go away. I'm going to go ahead and move this over because I know I'm going to need it. But this, again, will be simplified. We'll just say import file interactor. I'll do it alphabetically. Import CSV file interactor from file interactors.js. Excellent. So we'll need a create method. Let's go ahead and create that. Static create. This takes a file path and returns something. We'll need a delete file method. And then we will need a read lines method. All right, so that looks pretty good. That's all looking pretty simple. So let's go ahead and I'm going to start with the create method because the create is going to be the interesting part about this. Keep in mind, CSV file interactor is abstract. So what we're going to do here is we're going to say throw new error not implemented. We're going to do that on both of these because this is our abstract class. And what CSV file interactor.create is going to do is it's going to return a new file-based CSV file interactor. Now, I need this class, but I don't really need to make it public. No one really needs to know about it. So let's just create this really fast. We'll say this extends CSV file interactor. And now here we'll need to implement these two methods, plus we'll need a constructor. So we'll say constructor file path. Let's hold on to it. And now we'll need our two methods. I'm just going to copy these down. Delete file. I'm going to just pull from here. This is all we're doing. fs.rm sync and this underscore file path. And then read line. So I'm going to go ahead, I'm going to go ahead and delete this line now that I pulled that in. And then again, the same thing, we're going to read file sync and then split. Let's do the same thing. And this underscore file path. That now goes away. So that cleans all of this up. We're now returning all of those. It's extending that. This looks right. Let's go ahead and test it now. Let's make sure. All right, we do have a problem. File-based interactor cannot be invoked with new. Cannot be invoked without new. All right, and I need to call super. Syntax error, super keyword unexpected here. Oh, yes. Silly. In the constructor. That's right. There we go. And so now I've got my test passing again. So let's take a real quick review again. So app.js, what we did was we set up our facade in the database and we set up our strategy pattern. We've got those created. Everything's working exactly as it was before. So I haven't really changed anything. So let's go back to our README. We're now ready to add a test that shows the ideal state, but this is a good time to commit changes. So let's go ahead and do that really fast. So we'll say created a test that uses facade and strategy to mock the database and file for testing. We'll commit that. All right, that completes step 3. To add the test for step 4, let's head back into our test really fast. I'm going to create a brand new test, and it's not going to look anything like what we did before. So we'll say it loads transactions successfully. We'll just make it simple. This will need to be async, just like we did before. And now from here, let's talk through what we need to do. So we do need to reset the database, but we're going to do that through the facade. So we're simply going to tell the facade, hey, I want you to use an in-memory version instead of the actual database. We'll do the same thing with the connection information or the file information. So we'll set that up to tell the strategy pattern, don't use the file-based one, instead use the in-memory one. We'll call into main, we'll do the same assertions and make sure everything's reset. So let's work through that really fast. We'll say const in-memory database provider equals new in-memory database provider. So that's going to set up the in-memory database. We'll do the same thing in-memory CSV file interactor provider. So we're providing an in-memory CSV file interactor. So we'll get those set up. Those will do all the mocks and get everything ready to go. We will then do our try await main. And then in our finally, so unfortunately, JavaScript doesn't yet. There's supposed to be one coming soon. It doesn't have a disposal or a using pattern for disposable resources. So we will simply go into these objects that we created and dispose of them manually. So now that that's set up, all we're going to do is do our assertions, and I'm going to delegate these out to these providers. So again, that'll just keep this code clean. So we'll say in-memory database provider assert transactions count is 3. And then in the in-memory CSV provider, we'll say assert file was deleted. So that's our test. A lot simpler, a lot easier to read than what we were doing before. So we'll create our database provider, we'll create our CSV provider, we will call into main, we'll then assert on both of those and then dispose of everything at the end. If we had a try, some sort of disposing or some sort of using, the lines that go away are basically these lines here. So it just makes it even cleaner. Hopefully not too much longer we'll be able to use that as a part of Node programming where we can do, and I think the syntax is, I think it uses using, much like the C# version. So that'll just clean all this up. It'll be really nice when that's ready to go. All right, so we have that ready to go. What we need to do now is create these objects so that they pass. These are going to be inside my test file, my test code. So let's create a new file here. We'll call this test framework. We'll start with our in-memory database provider. And let's export that, as well as our in-memory CSV file interactor provider, which is a mouthful. And let's import those. All right, so those turn green. Those look good now. Now these are going to both need a dispose method, so let's add those really quickly. And we're going to need these two assert methods. So we'll start with the database one. And then the file was deleted. All right, so that looks like it's all set up and ready to go. I should be able to run the second test and get the same error that we were getting at the very original part of what we were doing. So let's run these real fast and let's see. First one still succeeds. Second one. Excellent. So it is trying to access the file. We're getting the same error we were getting before. So I like this error. I like that I'm getting this error. I can use this to know when I'm done as a part of this new test. Let's head back to our test framework and let's start implementing. So with these, I'm actually going to need a constructor on both of these as well. So let me go ahead and just create that in both of these and we'll talk through what we need to do here. So start with the database. The database is using a facade pattern. What we effectively need to do is tell the facade or something in the facade pattern that instead of doing what you normally do, I want you to do something different. I want you to call into me. So in this case, we're going to make this basically the database as well. This is going to be the in-memory database. So we'll start off by saying, creating our table, which is just going to be an array or a list inside JavaScript. So there's our table of transactions. Then once we have that set up, we're ready to add to it. What we're going to do is tell the facade, use this instead. So let's go to the database class. So we're going to need to import that. Source data, there we go. So we import that, and now we're going to basically say, instead of doing what you normally do, I want you to do this instead. So we're going to override the insert transaction behavior. So let's do that. Override insert transaction. And what we do instead is, given a transaction, what I want you to do is call into me. So we'll say this.transactions.push the transaction. We're going to just hold on to it. So we're going to set this override up. In our dispose, we're going to undo that. So we'll say reset insert transaction override. So we'll just say, okay, now stop doing what it is I told you to do. So we'll say, okay, for the life of this object, as long as this in-memory database provider exists as an object, do this, but once I dispose, undo that. So that's basically our setup there. Let's go and do the assertion, and then we'll move into the database class itself. The assertion is going to be simple. We'll simply say if this transactions.length not equal expected count, let's throw a new error. We expected blank transactions, but blank were found. All right, so there's our assertion. That looks pretty good. So let's head in the database class now. We need to implement this override insert transaction and this reset insert transaction override. So we'll head into the data folder or the data module, and let's set up, what do we call it? Override insert transaction. So we'll say static, and this will be basically a callback. This will be a function or lambda that we call instead. So we'll say insert transaction behavior. And then there's a reset insert transaction override. And all this method is going to do is it's going to call the override with null. Override insert transaction, null. Keeps wanting to add this in front. This is a static method. Don't add this. All right, so now that we've got that, we need to hold on to it. So we'll just say override equals that. So let's go ahead and create our field. Oh, just static. Okay, equals. So we'll default it to null. And then when we're done, we'll set it to null. And if it's not null, we'll actually do something with it. So that's our behavior. So now what we want to do is we want to use that inside here. Let me create some more room. So anywhere where we would normally go to the connection, we're not going to go to the connection instead. So we'll set that up right from the create. We'll say if that equals null, then we'll just return a new database. I'm sorry, let's think through this really fast. If it doesn't equal null, we're going to use that behavior. So if it doesn't equal null, we'll return a new database that does not have a connection. Otherwise, we'll create the connection. So if there is no override behavior, we'll create the connection and return the database. We'll do the same thing in dispose, or a similar thing in dispose. We'll say if, and here what I can do is the connection itself. So we'll say if this dot connection, so if there is a connection, then we will await the end. And then finally down here, we need to check for the behavior again. So if there is one of these, then what we're going to do is call into that behavior and then be done. So we will simply say, I think we could just return. So we'll simply invoke that behavior with the transaction. That's basically it. So again, once that's set up, we'll do these guard clauses, these guard statements to say, if that's defined, do something different. Otherwise, do what you were normally doing. So let's test this out and see what we've got going on. I do expect to still run into the same error that we were running into before. Okay, I do have another problem here. So I broke in the first test. So let's debug through the first test and see what we've got here. Insert transaction behavior override is not defined on the create. Let's see if I have to prefix it with the class name. That may be what it's complaining about here. All right, let's try this again. Yes, that looks like what it needed. So it needed the class name in front of the static field. Override insert transaction. Override insert transaction is not defined. And again, I probably need the class name in front of it. Let's try this again, see if we can get the correct error on the second one. And we do. Okay, so the first test is passing. The second test is failing for the same reason that we had before, because we haven't done anything with the file. So this is all set up now. I've got everything set up for that. So again, let's just review. So I did need the database class in front of the static methods and the static fields, but we're setting that up. And then once that is set up, if it's defined, we will short circuit and not do the normal behavior. Otherwise, we will do the normal behavior. So that gets us going there. That's our database. So now let's move on to the file interactor, the CSV file interactor. This is going to be similar. So we're going to go back to the strategy pattern and say, hey, override what we were doing before instead of what you normally do. So instead of a file-based CSV file interactor, I'm going to create an in-memory CSV file interactor. So I need a new class. I say that. I assume I do. Let's do this in JavaScript first. So what we're going to do is we're going to set up. We're going to go to the CSV file interactor class. And we're going to say set initializer to say whenever you need one of these, instead of doing what you normally do, I want you to create a new in-memory CSV file interactor from the file path. And I don't really even need the file path. The file path is not important, so I can do a discard here. So there's my setup. So I do need this class. We'll create this in just a moment. The dispose, we will simply reset that. And then on the assert, we're simply going to go into that. And so in this particular case, what we want to do is in-memory CSV file interactor. We're going to call into that class. Assert file was deleted. So we're going to delegate it back out to the other class here. So this class looks pretty simple. Let's go ahead and create our in-memory CSV file interactor. This does need a constructor that takes a file path. And we're not going to really do anything, so we're going to just discard file path. It's not important to us. And then in our method, so let's head back into the file interactors, we're going to need delete file and read lines. So delete file, we'll simply hold on to was file deleted equals true. Read lines, what we're going to need to do is return the lines back. So I actually need to go back to the test. And not only are we going to create one of these, I need to tell it what the contents are going to be. So let's go to a new file or a new object called example files, and we'll say example file 1. example file 1 contents. All right, so we'll create that. And so inside my interactive provider, inside the constructor, we're going to need the file contents. And now I need to pass that into the in-memory file interactor. So we are going to need this file contents. Equals file contents, and now I can use that. So what we will do is we will simply return this file contents dot split on the new line. So we're going to basically do, where's the file interactors? Basically going to do the same thing we were doing before. We're going to just split \r \n. So we're going to take the file contents as a string and just return that with a split on it directly as is. So that makes all this fairly simple. This all looks pretty good here. Now, going back to the test, example files doesn't exist. We'll need to come back to that. Let's go ahead and do that really fast while we're in here. So the example files, this is part of file interactors. I'm going to do it here inside this file here. So we'll create const example files equals, this is going to be a new object, and we'll need example file 1 contents is, and this will need to be from our example file 1. So let me copy these out. All right, so there's our contents for example file 1. Let's head back to the test and import this. Oh, I put this in the wrong place. This is in the CSV file interactor class. That is not where I wanted that. This should be as part of the test framework. This is where I wanted. I thought it was in the wrong class, or the other class. All right, so we'll export example files. Let's go back to our test, example files. Let's go back down. There we go. Now it's pulling the value back out. Perfect. So that is set up, ready to go. We'll head back to our test framework class. In here, this is all looking good. I think we're ready to do the set initializer and reset initializer in the CSV file interactor class. So let's head there, file interactors. So this is on the CSV file interactor class. We will create a static method, set initializer, and static method, reset initializer. The reset initializer is simply going to call set initializer with null. The set initializer is going to hold on to the initializer in a field called just underscore initializer. You can call it whatever you want. Let's set this up. Static initializer equals null. Now we're ready to use it. So again, just like we did before, we'll do a simple guard clause. If CSV file interactor initializer is not equal to null, then we will invoke that, return that with the file path value. Otherwise, we'll return the normal one that we typically do. That's basically it. Let's go ahead and head back to our test. Let's run our test now and see, okay, we do have a problem. Okay, we expected 3 transactions, but 1 were found. That's an interesting error. What it probably means is I have a problem, I have an error in reading the results. So let's see what these results look like. I have a feeling that my records is actually an object that probably has rows inside it. And it does. So this is an array that has 3 elements. So my actual records is that it's the array of that. Wait a second. It is an array with 3 objects inside it. Okay, that is confusing because that I would have expected that to actually make sense. Okay, so let's try this. Records retrieved. Records type. All right, let's log those off. It is an object. It's an object, even though it looks like it's an array. All right, let's do a quick internet search. MySQL, retrieve records from select. Oh, I need to say not just MySQL. Node MySQL retrieve. MySQL 2. All right, let's see what we've got here. Okay, so we are awaiting the query. So they're using decomposition. Let's do that really fast. I think this is supposed to be, let me try, I think it's actually .rows. Let me try this. Nope. All right, so looking at some of the examples, they were using decomposition. So say rows fields, return rows. And we don't really need that, which really just means we need that. All right, let's try that. Still expected 3, but 1 were found. That looks like an array. What is going on here? So it's returning a query result. All right, let's look for another example. Const rows decomposed from connection.query. Do I have, okay, let me think about this for a moment. Is this a misnomer? Because this code should only be called, I think that may have been okay. The first test is passing. Performs a system test. The system test is passing. The second test should never call that. So that's a misnomer. What we're actually saying is we only got one transaction in the database. Okay, so this may be a different problem. I've been going down the wrong avenue. I don't know that that was an issue. This definitely is working. That's the way that they're saying to do that with that library. But in this particular case, what we've got is we have an issue with, we expected 3, but there were 1. This is inside our test framework. This is our transactions.length. So we only called insert transaction once. Could this have to do with new line? Let's look at this for a moment. So in our test framework, here's our files. So we need to split on new line. Let's do that split here. Let's log that off and see if that is our problem. Yes, it is not lines \n. So it's not breaking where I thought it was going to break because probably the nature of the JavaScript file. So the in-memory version shouldn't split on \n/r. It should only split on \n. Let's try this now. Now I've got 3 lines. Now I've got a new error. Assert file was deleted is not a function. Did I not? Oh, I didn't. Okay, I did not create this on the actual in-memory file interactor. All right, so now we need to make sure that it was deleted. So we'll say if this was file deleted, and we'll say not, so throw new error, the file was not deleted. There we go, now we're passing. Let me get rid of my console log. We don't need that anymore. Run it again. Excellent, now our 2 tests are passing. It's a little bit of fun with JavaScript, trying to make sure everything is working correctly. All right, let's head back to the README now. We've got that up and running. So we've now created the code to make the test pass. I've kind of cleaned up as I've gone through, but I do want to do one more cleanup real fast. So everything in this file looks good. I like the order of everything. I like the structure of everything. That looks good. We'll close that. Let's go back. I'm going to leave our test open. I'm going to leave our app.js file open, so nothing to change there. File interactors. I think this file looks really good. So nothing to create or nothing to change there. Data.js. This looks good. I like that. And index.js, we can close that. All right, we've done our refactor. Let's commit our changes. Out the new acceptance tests to pass. Acceptance test, which models future tests to pass. All right, so commit, that would be a good time to commit and push if we had a central repository. That takes us through the refactor. We're now on step 7. We want to add a failing test representing a bug. 7, 8, 9, and 10 are going to go much faster than the previous few steps now that we have everything set up the way we'd like. So we'll start off with our test. We'll add a new test for the failing test, for one of these that's a bug. So I'm going to copy and paste my test, and we'll say loads transactions with a header row. I'll do one that has a header row. So I'll just pick example file 2. This one has this header row here. So we want to make sure that this file also runs correctly. So we'll say example file 2 contents. So let's head back to our test framework. Example file 2 contents. And let's copy these contents now. All right, and let's see if we get a failure. So let's rerun our tests, and we do. So we expected 3 transactions, but 4 were found. What's happening? It's loading the header row as a transaction, which is not correct. We want to make sure we ignore that header row. There are several ways to solve this problem. And by the way, we're now on step 8, which is fix the bug in the code. So there's several ways to solve this. I'm going to do this in the app.js file. We'll simply run through this and say, all right, looking at these lines, if the first line happens to be that header row, we'll remove that line and then move on. So just a quick guard clause. There are, again, lots of different ways to do this. We might need to go back to the customer and say, hey, do you always send the same header row? Do we have this happening with multiple customers? Maybe they have different kinds of header rows. So I'm going to pretend like we've talked with the customer and they always send us back the same header row if they send it, which are these values. So I'm just going to hard code this into my code then. If I know it's always that way, we'll say if lines 0 equals this, then lines equals lines dot splice, we start at 1. I believe it's just splice 1. And then we'll run through the lines. Let's run our test and let's see if I've got that correctly. So I set this, yes, this is const. We'll need to change this to let. Let. All right, let's try that again. And we're passing. So I now have the one with the header row. I've spliced the first line, and we have verified that we do in fact have, let me get back to the test, we do in fact have 3 records. So that takes care of the bug in the code. We've ensured that all tests have passed. Let's do one more round of cleanup really fast. App.js, is there anything I want to change here? I'm going to create a little line here. I think that's going to make sense. Let's also add a header a comment here. We'll say, if there is a header row, ignore it. I could even move this to its own method if I wanted to just pull it out of here. That would help with the readability as well, but I think we're in good shape. So if there is one of those, I'm going to go ahead and get rid of the curly braces because we don't need those. I think that looks good. Let's run the test again. Make sure I didn't break anything. Everything still passes. We're ready to commit one final time. Fix the bug where a header row caused an extra record to be inserted into the database. Again, a good time to push, but that's how fast, what was that, about 4 minutes? That's how fast we were able to create a new test, fix it, demonstrate that it's fixed, and demonstrate that everything else is still working. Back to the README, that concludes the Gold Belt Kata. So again, hopefully you're able to see how we're able to use the facade pattern, how we're able to use the strategy pattern, how we're able to tie everything together with our tests. At some point, it's probably worth looking at this system test here, this first one, and actually commenting it out or getting rid of it, moving it to another file. This test doesn't necessarily belong going forward. It's nice to still have. I don't want to throw it away because if something else goes wrong, it's good to make sure that I've got this as a fallback, but it's probably not a test I want to always run all the time since I've got these other tests that are going to run faster. They're going to mock the things that I need to do and make sure that very quickly we're able to get to a point where we can test fast.